Hello and welcome back to the Armorial Railway and the building of Little Drawling. Well, in the last video we saw that we managed to get some trains running over the tracks. Very satisfying for me to finally see something running across the baseboard. But you may remember that the locos were stalling at the points because we didn't have any power to them. So that's what we're going to deal with in this video. We're going to get some power to the points. I'm doing lots of studying of various wire diagrams. Proving slightly difficult for me, as you know. I'm not really very good at the electrical side, so in my head, for ease, I split it down into three distinct areas. The first of those is the non-DCC bus wire that gets the power to all of the non-DCC operated points. So that's what we're going to look at now. We're across at the baseboard where we need to fit up that DC or non-DC bus wire. So I'll meet you across there in just a second. So here we are at the baseboards, and as we said, we're going to focus on initially getting the non-DCC power to the track and the various assets that need to be powered by it. I'm not going to show you how I'm going to fit the base wire. It's basically as we did for the running the DCC bus wire through, except I'm going to bring it closer to the edge of the baseboard, so running along the edge rather than the centre. Just so I know which of the two are. So as I said, I've already done that in a previous video, so I won't go through that. The other thing that I'm going to do is I'm going to fit somewhere for the controller to go. So as you know, the controller at the moment has been just sat on top of the baseboards. So I'm going to run something along here. My plan is to use a bit of old flooring that I found. So this bit of flooring here, I'm going to turn it this way around, cut it to size. I have one bit up here which the controller will fit on, and then the other section of it will be for the point switches that will go down here. So what I will do is do the base wire and then fit this, do the bus wire and then fit this, and then I'll meet you back at the baseboards. But in the meantime, if we go back over to the table, we can have a look at the various bits of wiring that we're going to need to do in order to, first of all, get power so that we can switch the points, but also make sure that the polarity within the points is correct using the polarity switcher on the point motor. So I'll let you go across there and I'll crack on with this. Well, as I think I said, the electronics for the point switching all in one go is just a little bit too complicated for my tiny little brain. So what I've planned to do is to split it down into a number of simple sections, and I'll just go through what those are. The first one is going to be the providing the power to the bus wire, and then from the bus wire to the capacitor discharge unit. You may remember this unit from this old Hornby controller from the very first video, and I said I'd see if I can get it working. Well, unfortunately the DC part of it doesn't appear to be working, but however it does have an AC output on the back. It says 15 volts AC output on the back here, and the capacitor units that I'm using require a AC supply rather than the DC supply that came with my digital controller. So I now need to check whether this is actually going to be giving me any power. So I've got a little monitor to enable me to see whether there is any power coming out of the AC supply. So what I will do is I will do that in just a second, and let's see how well it works. So here we are then. I've got the Hold Hornby controller. This is the AC bit here, so that's the two AC bits here. So I've got it switched on. Yep, it's switched on. So now we need to do is to switch on this little tester here, and we'll see if we can get any power to it. Let me just switch this on. It's registering 0 at the moment. I'll attach these to the two output terminals, and I'm not sure whether you can see that. I'll just try and hold these two on. And a little bit of I can feel the power coming through my finger where I'm holding them both together. So we've got about 17 volts coming out of there. So it's more than the 15, but it's clearly some voltage coming out of there, and if I hold them both steady it does level off at a fairly constant sort of 17.86 to 88. So it's a fairly constant AC supply that's coming out of there. So I know that this is now working, so I can use this unit to supply the main AC bus wire that will run along, that we're currently fitting, as you saw a little bit earlier in the video. Right, so I must remember to switch this off. And what I'll do now is I'll quickly grab one of the capacitor units and talk a little bit about that. So here's the capacitor discharge unit that I'm using. The reason I've decided to use these, lots of people have recommended using a CDUs to power the solenoid point motor. Basically what it does is it gives you a short supply of power to the motor, rather than if you didn't have one of these it would be a slightly longer supply as long as you had the switched on. This gives you a short bout of power, fairly constant, a bit more. It also enables you to run more than one point motor off of one of these, so rather than them having to come off of each one or each of the bus wires. So I can just run about 3 into here and then just have the bus wire running into each of these. So that's my plan anyway. What I did find though, and I'll just take this out and show you one of the things that I did find when I was first looking at these. So the discharge unit does have on the back, it has an out sign and an in sign. So clearly the in bit is where the AC voltage comes in, and the out bit is where the AC voltage comes out. One of the things I struggled with a little bit was to work out, however, which way the wires went round. So I don't know if you can see this, but on the unit we've got, on the outside we have a minus, plus, and then it looks like then a minus, and then the 24 volts sign. On the diagram that comes with it that explains how it works, it does show the 16 to 25 volts coming in from here, so I'm fine with my 17 to 18 volts coming in, but it doesn't show whether it's plus or minus, which plus and minus wire there, and which is the output, which is the plus and minus wire. And I must admit I did struggle a little bit trying to work out what it looked like. To me it appeared that it runs as follows. So there's the positive here represents both of these two, and I worked that out roughly because of the way they were. So it goes negative or 0 volts, the 16 to 24 volts input, and then the 16 to 24 volts output, and then the 0 volts return. So that's the way I looked at it. In order to check that, what I actually did, I wasn't quite sure. I was asking people on one of the Facebook pages, and someone just suggested wiring it up and then attaching it to this unit and seeing. And in fact, when I did that, that is the way it worked. So the two bus wires that are being set up at the moment will have some wire coming out of them, so wire coming out that will run into the input side of this. So we'll run into these two here with a 0 volts, and then the 24 volts, and then 16 to 24, 16 to 24, and the 0 volts out, and this will then run out. So if you have a look at the small diagram here, so the bit that we've covered so far, we're laying the bus wires down here, they'll connect in here, and then the output bit will then come out of here. So that's the bit we're setting up at the moment. And then so that's my understanding of how that works, and I think I've now got my head around that, and that's the first bit that we've done. The next bit is to set up the output then into the switch. And I'll just go and show you one of the switches that I'm going to be using. So here's the switch that I'm going to use, and I've already got a red wire attached to that, and I'll explain that now. So my intention here is to try and colour code the wires just for my ease of understanding. So anything from the bus wire to here will be the same colour as the bus wire. So the wire coming into here will be, just double check that, so the wire coming in onto the 0 volts will be blue, and the wire coming in on the 16 to 25 volts or 24 volts will be the brown wire, the same colour as the bus wire. The outputs from here I plan to have slightly different. So the output from this one will in fact be a red wire, and the red wire will run through and attach to the switch. So if I show you the diagram here, so the output red wire here runs along and goes into the centre point on the switch, so the centre one here. So eventually, once I've got this fitted and the switch fitted, that will run into there like that. The following two wires here that were attached to the two sides here, which are these two wires, if you look on the diagram here, because we're now talking about the section from the switch to the power to the point motor, which will actually make the motor move. So these two wires are both going to be black wires. So there'll be a black wire there, a black wire there, and they will run to either side of the point motor. So what I shall do in just a second is I'll show you how the point motor looks like, the point motor that I'm using, and how that will then get wired up. So here's the point motor that I'm using. It's the Gauge Master SEEP motor. What I'll do now is open it and show you what it looks like inside and the various connections. So here you go, there's the SEEP motor in its entirety, fresh out of the box. Moves backwards and forwards nicely. And here's the instructions that come with it. As you can see, they're rather small. Also, I'm not really sure they fully explain what to do. I'm sure to those confident in electronics it's fairly obvious. So I've needed to watch a number of videos and look at a number of online diagrams about how these go. Some of them are fairly straightforward, and what I've done is I sort of transferred this onto a bigger sheet of paper to help me understand it. And what I'll do is I'll talk about the second section that we were on about before, so the bit that runs from the discharge unit to the bit that actually activates the point, so the bit that actually makes the point motor move, because that's the second bit that we are focusing on in terms of the wiring of the setup. So I'll do that now. So what I've done, bit of a copy from Everard Junction, I suppose, for those of you that watch his channel, those of you that don't. It is a very useful channel, in fact, I find it is anyway, particularly for those new to model railwaying. What I've done is transferred that diagram onto here. So there are in effect a number of connections or places to solder to along here. I think some of the more modern versions of this are solderless, so you can actually screw them in, but gives me a chance to refocus in on my soldering technique. So the ones that I'm interested in initially are the ones that run from the switch. So I said there are two connections on the outside of the switch. These will be running off, and when I push it that way, clearly it will connect to that. It will take the power that's coming into there out through that side, and when I push the switch the opposite way, it will take the power that's coming in from there out via that. So these two will in effect decide which way the point motor will be going. And if you look here, so we've got an A and a B, and so those two go to the outer point motor. So that will run to that side, and that one will run to that side. Now what I've done is colour coded these black, so these two are black. So that allows the power to come in, and what we then need is power to come out of the point motor to make the circuit. So when I flick the switch, in effect the power will come from the burst of power will come from the capacitor discharge unit out, in through either of these two, depending on which way I've flicked the switch, and then it will go out through C, which I've marked as AC, and 0 volts. So go out through there and back in via the capacitor discharge unit. So that's the process that, in terms of the second bit of the wiring diagram. So what I will do is I'll wire this seat motor up now to reflect those three wires. So two black. I've marked that one blue because it's a blue wire that will be coming back, that comes into the negative ear. It does mean that I've got two blue wires, but I'll come on to that in just a second. So I need to wire A and B with black wire, and I need to wire C with some blue wire. What I will need to do is to make sure that those are long enough for where the point motor is going to go back to where the switch is. So I'll go and measure that up, and then I'll wire it up, and then I'll show you what that looks like. So there we go, we've soldered the three wires that run to either the switch or back to the capacitor unit. So if you remember rightly, these two wires, the two black wires, this one and this one, will be connected to the switch as per the diagram there, and the blue wire will connect straight back into the 0 volt AC part of the output from the capacitor unit. So that's the second bit of the wiring that we need to worry about. So far we've covered the wire from the bus wire through to the input to the capacitor unit, and now we've covered the output for the capacitor unit via the switch into the point motor, the SEEP point motor, and back into the capacitor unit. The next bit is the power to the frog. What I'll do now is I'll use the other diagram again just to quickly explain how I understand this bit works. So let me just get rid of these things out of the way. So here we are then. What we've got here is one of the short outturn Electro Frog Points, and if you remember rightly, the first thing we would need to do is to cut these two here. I haven't done it on this one. Cut these two wires here, and what that in effect does is it means that the whole of this section here has no power going to it. And if you remember in the previous video when I showed the trains running, the moment they got here they in effect stalled because there's no power coming to here. There's still power coming to that rail and power coming to that rail, providing I've connected these two correctly, but and there's power coming down here and down here depending on which way this point is switched. So you remember also what we did is we removed one of those and we connected a wire directly across the two sections of track. So in effect we joined that connection to that connection and that connection to that connection, so that all of that is live and all of that permanently is live to the same as that one there. All of that is live and all of that is live, but basically the same as that there. So if you imagine this point is sat on the track like that, from my point of view that's a live wire, so that's the DCC 16 volts, and that's the negative or the DCC 0 volts. So the same thing here, that will be 0 volts and that will be 12 volts DCC. So, but this will have nothing at the moment. So if you have a now look at the diagram here, what we've got is some input from the DCC. So this will coming in from the DCC power coming in onto the D part of the seat motor, and this will be coming in a blue wire, so that's brown because it matches my bus wire, and this will be a blue coming in from the 0 volt. So we will have, in effect, power coming in from either of the two rails will be coming in. And here we have on the F diagram here, just make sure you can see that. So on the F diagram here, we have an output going out to the frog. So in effect, that's this connection here to the wire here. Yeah, that wire there. So what that means is that somewhere there is power coming out from there to this wire, and therefore is going to power the what was the neutral frog, so or the isolated frog. And that will depend on which way the seat motor switched. So if it switched to that side, then the power will come in from here and out there. So that will give that one the DCC, 12 volt DCC. If it switched this side, the power will come in from the 0 volt DCC and out through the frog there. So what that will in effect mean, if we now have a look at the frog again, so with the point motor switched across, so that rail there, assuming this is back on the track layout, so that wire, that track there is going to be the 12 volt DCC. So when it's switched across, in effect, it will pick up the power from that bus wire and feed it to here. So in effect, all of that and that will now be 12 volt DCC, and all of this will remain the 0 volt DCC. When it switches back the other way, in effect that now takes the power from this track or from this bus wire, so the 0 volts or the DCC to the bus wire. So in effect we have, and it's going straight on, so in effect that track there will be 12 volts DCC, and all of that now becomes 0 volts DCC. So that prevents the shorting out of the frog. So that's the Electro Frog Points, how I understand it. All I now need to do is clearly wire up these, D, E and F, in accordance with that. So a brown wire coming into D, a blue wire coming into E, and I have got two blue wires, so I just need to remember which one's which, and the F wire coming into green. I know that's not ideal having two blue wires, just the way my bus wires are, and it helps me understanding a little bit anyway, so as long as I understand it for my layout, you can clearly, anybody else doing it may wire it up slightly different in terms of the colours. So I shall now wire up the rest of the seat motor so you can see what I mean by that. So here we are, all soldered in now. So the three wires that I've just soldered in is the brown wire that of course runs to the 12 volt DCC bus wire, or it'll probably run and join up with the one that's powering the actual track anyway. And then the blue wire, second blue wire, the centre blue wire, which runs to the 0 volts DCC bus wire, and then the green wire, which runs directly to the frog. So we've now got the three different sections that in my mind make it easier for me to understand what I'm doing. The first bit is the bus, so the AC bus wire cable to the capacitor discharge unit, and then the output from the capacitor discharge unit into the switch, and then coming in via the two black wires, and then returning back to the capacitor discharge unit via that blue wire, and that in effect operates the switching section. And then the bit that operates the frog is the blue wire, the brown wire from the 12 volt DCC track or bus wire, and the blue wire that comes in from the 0 volts DCC bus wire, and then the green wire that runs to the Electro Frog, so the centre bit of the frog. So Having done that, I think I understand it in my own head. The next thing to do is to go across, have a quick look at the baseboard, see how we've got on in terms of fitting the bus wire, and then begin to connect it in that order, starting with the capacitor discharge unit. So once I've done that, we'll go back over, I'll be back and we'll see if we can get one of the points working. So, see you in a bit. Well, we've wired up the electrics to the first point and wired the switch in. I've not wired up it to the Electro Frog bit yet, but just to check whether the frog is switching over. And as you can see, it does appear to be working correctly. It was a little bit temperamental at first, but now it does appear to be turning and throwing it all the way across. So all I've got to do now I've got that done, is wire it up to the Electro Frog bit, so wire in the polarity switching bit, and if that works I can run the first train over the first point. Well, there we go, not too bad at all for a first effort. Well, first point has been all wired up now. There were some problems around the polarity switching, which I'll cover right at the very end and explain what I did wrong. But I'll just show you the little Ginty engine running across it so that you can see that it's all working fine. Here comes the little Ginty. Points are pointing in the right direction. Hopefully it will run straight across. There you go, so the Electro Frog's working. If I switch the switch, I can now run the Ginty back over it. It runs fine running across. Let's take him back again. Sorry about that, I had something covering the track and I was trying to work out why. As soon as I switched the switch it was shorting out. The culprit left across the tracks. Anyway, let's take her back. And then I'll run it one more time just to make absolutely certain that it is all okay. Right, let's flick the switch back again. Here comes the Ginty, straight across, and I'll run him off up the main. The little jutter there you saw was I haven't quite cut the wire low enough that switches the points. And it was a lot more harder the little wire here. I found it a lot more harder to cut than I thought it was going to be, so I need to get some better clippers to actually clip it a little bit lower down. Both the Ginty and the RSO8 tend to catch on it a little bit. However, that's for a later stage. What I'll do now is set up the other three main points that I want to do today, and then we'll see them running both the 08 and the Ginty running across, and then I'll explain very briefly the problem with the polarity switching. So, I'm pleased. Well, I've not quite got as far as I was hoping. I've been having some real problems with this particular point here that seems to be not correctly wiring up correctly. I'm not sure whether I've got some dry solder, some dry soldering points on there. I've managed to get it working and it's now shorting out. I think I need to turn the wires around at the bottom again, and that was one of the problems I've had with all of them, was that the wiring diagram I had didn't quite reflect the way I was expecting it to, so I've had to play around a little bit with the wires. What I'm going to do, because this is now upsetting the rest of the layout, so this particular point's upsetting the way the other points seem to be running, I'm going to actually lift this one completely, resolder all the joints, and then I'm going to try and relay it. But I'm not going to be able to do that for a short while because I'm currently quite busy at the moment. So I think I'll end the video there, and hopefully when we come back next month we will have finished this particular section of track with all the points and all the point motors working. The point motor's working on this track, it's just not, the polarity doesn't appear to be working, and because the polarity is not working it seems to throw all the others into a little bit of off kilter, and it seems to be causing the things not to run very well elsewhere. So I will lift this one and redo that, and hopefully when we come back next month for the next video, this will be completed, and I'm hoping to get the remainder of the track laid so that I can actually start on the platform section of the track. So I'll see you next month.